So today we will see two things. One is about the JVM threads scheduler, and another thing that we have to see is how can we pass data to any of the thread and get the completed data, or after the operation the result will be produced, and see how to get back that result. For that, I have a requirement. You people got to tell me that how can we solve that. Okay, so I'll create one more class. This is full of code, so do not want this. I'll create that. Before that, you tell me. I will take input of some string and I have to reverse that particular string, and I should get that reverse string as output or as a return value. So how are we going to solve this particular problem?
Get the string from user and using string buffer, we can reverse this.
Good. So where are you going to write this particular? I do not want to be it in main method.
Can we create some static method on?
We can create some static method. Very good. And we can pass the string as an argument and get it as a get back it as a return string. Okay, cool. Everybody is with this particular strategy of giving a string to a method and reversing it using string builder and getting back that reversed string. Everybody clear? Everybody knows how to do this? This is a very basic thing. Hello, everybody.
Yes, sir.
Okay. So now I tell you that I do not want to run it in one single thread, which is actually running, that is main thread. I do not want that to be run in main thread. I want that to be executed in another thread of execution, and then I get that output. How can I do that? How can I do that? Hello? Guys, you need to answer. I have a string. Okay. And I need to send this string to another thread, and that thread should reverse the string and send back the result, that reversed string, back to this main thread. How can we do that?
Sir, I have an idea. You can write the reversing code in the run method of another class, which you in some other class, and you can store the string in either a string array or an array list or something, so that whenever whatever you modify there is also reflected in the main method.
How do you send this string?
You can use you can make an instance variable in the other class and then pass it when we're creating the thread object.
Correct. Very good. So you would have got an int if you had read that particular thread documentation yesterday I sent you. It is there in the first view itself. You can, how can you send something, some thread, some data, and return it back? Okay. So today we are going to discuss this particular thing, that how can we send data to another thread and get that data whatever we want. Okay. So how are we going to do that is, we'll create that job. okay, by implementing runnable interface and create a parameterized constructor to receive data whenever that particular thread object is created or that runnable object is created. Then we will give store the data in that instance variable. Then we will provide another. Can we do this? Suppose I create another class, okay, reverse string thread dot reverse. Generally runnable interfaces are named like job, reverse string job dot java. Okay, how are we going to create it as a thread? We should implement
thread class.
Implements runnable, not thread class. We can of course extend thread class, but we are not going to do that. So can we do this? We have to override run method. We will override run and receive some string str, okay, reverse the string and return string. Can we do this?
No, sir, we
Hello?
can't do
No,
this.
sir.
No, why?
We can't able to change the header of the
We
thing.
cannot change the header of the method that we have overridden. So we cannot do this. It should be void. It should be empty parameter. Okay. So, but we should do the logic thing here, and we have to accept data. The only way that we can accept data for this particular thread is by providing a parameterized constructor, public reverse string job and receive string str, okay. Then we will have a instance variable string reverse str. That's it. Okay. So, and we will also have another string str. So this dot str equal to str will receive that string, and inside this run method, what are we going to do? What is the program logic? What is the requirement? Hello? What was the requirement?
Reversing the string.
Reversing the string. How do we do that?
If str length more than 0.
No. Give me simple solution, guys. Use library methods.
String builder SB is equal to new string builder.
Yeah. String builder SB equal to new string builder of str, right? And reverse str equal to SB dot reverse of. That's it. It gives you what happened.
So convert it to string.
Yeah, correct. To string dot SB dot reverse of. No.
To string come after SB dot reverse.
Yeah, correct. Sorry. Something else is going on in my mind. Okay. So that's it. So how do we return back the reverse string? Reversed string. Hello?
No idea, sir.
Just create one more static, not a static method, an instance method, which returns the reverse string. That's it. So simple solution. No need to think much. Okay, get reverse str. So it will just return reverse str. This is how we pass data to a thread, perform some action upon that data, and whenever we need that data, we can retrieve it using another method. Okay, now I will go back here to create threads. So I have this string. So I want to send it to the reverse string job and reverse it in another thread of execution. How can I do that? We have to create what?
Thread.
Create object of thread, right? We will create
Thread object. we have to create.
reverse string job job1
Yes,
equal to new reverse string job of and pass str. Okay, str. So here we are passing the data to the constructor and saving it as the instance variable in that particular class, in that particular thread object, okay, or this runnable object. Now we have to do what? Next step. Have we created thread?
No.
No, we have not created thread. We have created the object of that
Thread.
class which implements runnable. We have to create thread out of this object. How do we create that?
Thread.
Thread
New thread. Thread is equal to
thread
new thread.
equal to new thread of
Job 1.
job 1. Good. Then in which state is this thread? Now in which state is this thread? Is in. Okay, we'll talk about that later. Now what is the next step?
Start.
On the thread.
Yeah, we have to start the thread in order to start the execution, right? Thread dot start. Okay, but I have given the data and I am doing some operation in the separate thread of execution, but I want to print that result that was reversed by that particular thread. How can I get that? And how can I do that in this particular method? I have to print that result. How do I do that? Basically, can I do this? Job1 dot get reverse string. Will this print the reverse string?
No, sir.
Why?
Maybe, maybe not.
Because our main code is in our run method.
Then why will it not? If I call start, it should print the reverse string, right? Because after we call start, run method is called and it runs and reverses the string, and the reverse string will get the reverse string which is stored in that particular reverse string object or a reverse string string reference. Will it not give the result? Let's cut this. or what do you think will it give as the output?
Either null or the reverse.
We do not know. We do not know, right? But I should get this printed. How can I achieve that? So we'll just run this and see what do we get as output. You see, main started, but reverse string is null and main ended. But I want that reverse string to be printed. How can I do that? We have discussed this yesterday.
So can we use join?
Yeah, exactly. So what we do is we'll start the thread, we will wait until that thread of execution is completed to get the result, and then we get the result, then we end the main thread. This is how we give the data and to another thread of execution through a parameterized constructor and start the thread of execution, and after the completion of that thread of execution we will get the data from another instance method like get reverse string, and we will wait until this, because we know that this thread of this result waits or depends upon the completion of this thread of execution. Once that run method is completed, we are sure that that particular thread is completed, and now we get the proper result. How can we wait? We will use, or we should use, join method. So how do we call join method? Thread dot join, and it gives rise to exception. We have to surround it with try catch.
Try catch.
Okay, so we'll put all this code here inside try catch. So now we will run and see what happens. So we will also print actual string. String equal to str, and reverse string is equal to this. So now we will run. So string is this, main started, string is this, reverse string is this, and main ended. So now do you understand the importance of join method? Why do we actually use join method? Hello?
So
Any doubts, any questions, anything that you did not understand that you need me to repeat?
Yeah, sir. Please repeat. Yeah.
Okay. So you see, did you understand how should we or how can we pass data to another thread? We have data in one thread, and we have to pass that data to another thread, and based on that data we do some operations and we should get back the result. This is the base requirement for this particular thing. Okay, so we cannot pass data to run method, or we cannot return any data from the run method, because that is syntactically fixed, that we can start the thread of execution only by starting the thread, and inside thread that run method will be called, and that run method's header is fixed. We cannot accept any parameter to that run method, or we cannot, nor we can send back any data, return any data from that run method. But there are some scenarios there will be some scenarios where we have to send some data to that thread, and based on that data, we will do some operation on that data, and we have to return back that data. Okay. How are we going to do that? We cannot do it using run method, that we are sure, right? But there is a way where we can accept data when during the creation of that particular thread object or runnable or that particular class object which implements runnable. So we will receive that as the constructor argument, store that data in one of the instance variable, then use that particular data in run method, and then return that data using another another instance method. Okay. So many things are going on here, so many sounds, noise everywhere, so I'm getting distracted. So now we return the data using another instance method, and we can access it using the same object that we have created on that particular class. So we are sending the data when we are creating the object of that particular reverse string job. Then we are creating the thread using that job. Then we are starting that thread. So we have sent the data, started another thread of execution, but we should wait until that thread of execution is completed and on that particular data, and we have to get the result back. If we do not wait using this join operation, then it is sure that or we are not sure that whether the data is manipulated or used, or that particular thread of execution is completed and we get the result whatever it should produce. So we have to use join until and unless that particular thread of execution is completed. We should wait for the result, then we can get the result from that thread of execution and use it as we need it. Clear? You send the data, send the data. I just recap it very shortly. You send the data using parameterized constructor, create the thread, start the thread, and wait till that thread of execution gets completed, and use that result in whatever way that you need. Clear?
Yes, sir.
Any other
So-
question? Anything
So-
else? Yeah.
So we are waiting after starting the thread. So how does this kind of help us save time?
No, it will not.
Why
This
are
is
we doing
how-
this?
Here you have only one thread. Suppose if you have multiple jobs like the same thing, so then it will help. Okay, here it will not save you time, because it is how that works.
Yes, sir, I
Here-
understand.
Yeah,
Yes,
I
yes.
got it. Here you are telling that it is multiple threads, and you say that multiple threads will save the time. But here you are making it as sequential. It is like sequential execution, right? You start a thread, you wait for that, and then you get it. Otherwise, we would have done all these things in the same thread itself, which would have been faster, right? But
Yes.
if there exist some scenarios like this, when you do not want to run some jobs in the same thread, it should run simultaneously, and you have very few lines of code here, right? But when you have hundreds lines of code that needs to be run in another thread, and at the same time you wait for something, or you can do some other operations in between, right? Here.
Yes, sir, I got the idea. I just
Yeah.
didn't think well.
So in between, you can do so many operations here until we do not know when this thread will get over. But when you want to access the data, so you call join. If it did not complete, then it will wait for completion. Then you will get the result. Okay.
Yes, sir. Clear.
Okay. Cool. Good thinking. So this is how I also thought. What is the use? We do not get any use when we are doing these petty problems. So we will get all this use when we are doing all or implementing all these things in a bigger problems. Okay. Cool. Any other questions? No questions? Everything clear? So this is how we use join. This is how we send the data to another thread. This is how we wait for that thread to complete. Then we use that calculated data as a for whatever purpose we need it. Okay. Then another thing is we will talk about thread scheduler. Okay. So I'll go back here. So as I told yesterday, a thread will have a priority, will have a state, and will have a name. Okay, these three attributes they have. So we can control we can change the name, and we have control over the name of the thread. We can change even the priority of the thread, and we do not know whether that affects or not the thread that affects the way that the JVM runs the thread. We are not sure. And we have something called as state, which we do not have any control over that. So JVM has someone called as the JVM thread scheduler. That thread scheduler schedules the thread state. Okay. As I told, there are these 5 states for a thread. So when you create a thread object, it enters the new state. Okay. When you call the start method on that particular thread, it enters a state called as runnable state, and JVM thread scheduler maintains something called as runnable pool. Okay. This you can consider it as runnable pool. So you have multiple threads, and you have called start on all the threads. You have thread 1, thread 2, thread 3, and you have called start on all the threads, and all those threads will enter this runnable pool. Can you imagine? So like you have, sorry. You have T1, you called start on T1, you have first thread that enters runnable state is main. Okay, then T1 enters when you call start, T2 enters runnable pool. Like this, all the threads will enter this runnable pool when you call start method on them. Clear?
Sir, not clear. So doubt like a string pool has all these strings within within the memory area. What I understand is the runnable pool is also some memory area, and all the thread objects that are created and after calling start go there, or something like that.
Yeah, maybe you can consider like that. Thread scheduler is a program. It will use some memory, of course, and it will use some memory to have some memory like which are all the threads that is there in the runnable pool. Okay. Yeah, you can consider it as some kind of memory.
No, so my question is, will the thread object we created, will that be in the heap or will that be in the runnable pool?
Yeah, that will be in the heap. It's nothing to do with the memory object and everything. Nothing. It is just a kind of table that it stores that these are all the threads that are in the runnable state. When it will that particular table can be called as runnable pool. Okay, it will
Okay,
just
sir.
maintain the names of the threads which are in the runnable pool. It is
Okay,
all
okay.
maintained by something called as JVM thread scheduler. I'll just
Okay, sir.
write it. The no object creation, no string pool has any relation with this topic. Okay, JVM thread scheduler. Okay, this is all the job of JVM thread scheduler. When you create the object of the thread, it will put that thread to new state, or it will assign the state to that thread as new. Okay, once you call start on that thread, it will assign the state of that thread to be runnable. It's just a label you can think of, or it may you can think of that there is a table where it stores all the threads on which start method is called. Got it?
Okay, sir.
Okay, cool. So now for any thread that is in the runnable pool is eligible to go into running state. Okay, and we do not know at what point of time, at what thread will go into running state. It is all maintained by thread scheduler. If it wishes, so if there is only one thread, so that one thread will be in the runnable pool. If until now we had only one thread which was main, so that when we did Java space class name, this main thread would start and it would enter into runnable. Since no other threads are there in runnable pool, it would enter into running state, it would complete the execution, and it would enter into dead state. Okay, but when we create other threads and call start upon that, we have multiple threads in this runnable pool. So it is now the task of JVM thread scheduler that will assign or that will pull this out, any one of the thread from the runnable state to running state. So starting, it will of course start with main because that is the starting point. But at any point of time, you create the thread and call start, it can push back this particular running thread back to runnable and pull back some other thread to running state and make it run for some time and push it back to runnable state, pick it any other thread. So this is how it works. The JVM scheduler works. So it pulls back the main if it needed, or it pulls back T1, or it pulls back T2, or it pulls back the main thread again. So you have runnable pool, you have main here. So main is runnable. It comes to this running state. It runs for certain time. When there is some other thread, so it tells, okay, main, you wait, you go back to runnable pool. I will take T1 and I will execute it. So for certain time, T1 gets executed and it tells, okay, T1, you go back to runnable pool and I pick up main again and I will execute that. So it picks up main and executes for some time. And if nothing is there in the main method to run or execute, then it goes to dead state. Okay. So again, it comes back. The thread scheduler tells that, okay, T1, T2 are there. I'll pick up T1 again. Okay. So T1 is picked up. T1 is executed and it executes for certain time and it pushes back to T1 and it pulls back the T2 to running state. So this is how we cannot tell that it will pick up main thread only and finishes it. It will pick up T1 only and finishes it, and T2 only and finishes it. So at any given point of time, only one thread can be in running state, and we do not know which thread will be scheduled to running state. Okay, but there is another particular state which is called as blocked or waiting state. A thread enters to that state when you call some methods like sleep, yield, and join. When you call sleep on that particular thread, it enters the blocked state for that amount of milliseconds and then enters back to runnable. Okay. When you call yield, yield means give way to another thread. So it will come back to blocked state and go back to runnable state. When you call join, it waits as a blocked state until that running or that particular thread is running and goes to dead state, and then it comes back to runnable and running state. So this is how JVM thread scheduler works. I'll just recap. So when you create a thread, it creates it as, or it assigns the state as new to it. When you create or when you call start on that thread, that particular thread enters into the runnable state, and it is JVM thread scheduler's job that to pull it to the running state. So once that thread is completed, it will enter the dead state. So this is the happy path of a thread. Okay, so you create a thread, enters the new, and you call start on that thread, it enters runnable, and JVM thread scheduler will pull it to the running state whenever it wishes. Then after completion of that thread of execution, it enters dead state. But if you want to interrupt that any one of the threads execution, you can call some methods like sleep, yield, and join. So these methods will make that thread to wait. Okay, and it enters that blocked, that thread is blocked. It will not allow to continue the execution. So it will enter the blocked state. If you call sleep, it will wait for that particular amount of time. If you call yield, it will enter blocked state and again immediately enters the runnable. And if you call join, it will joins a particular thread or it waits for one of the thread to on which you call join to complete, to go into dead state, and then it will enter again back to runnable state. And again from runnable state, it is JVM thread scheduler's wish to pick up any one of the thread and go into running state. So this is how thread scheduler works and assigns different states to the thread. Clear? Any questions? If you are not understood anything, give me.
So like a runnable pool,
Yeah.
does the JVM also allocate something like a running pool, blocked pool, and things like
No,
that?
there is no running pool. There is no running pool. There can be only one thread that can be running at given
Correct.
point of time. Okay.
So if the state is not running means then it will come back to the runnable.
Yeah. If it is not completed, if main is not completed, yeah. So first time when the main thread got started, main is runnable. So JVM thread sees that until you start another thread, there is only main thread is running. So it is in the running state. Okay. Now JVM encounters some thread or JVM thread scheduler sees that in runnable pool any other threads are there or not. So if it is there, it is its wish. It can complete the main thread and come back and take some other thread, or it will tell main to go back to runnable and take up T1 and keep running that T1 and push back that T1 and take T2 to running and push back the T2, take T1 or complete main. So it is all depends on these things depends on JVM thread scheduler. Okay.
Yes, sir.
There can be blocked threads, multiple blocked threads. So that depends on how you call sleep, yield, or join. Any other questions?
So sleep
And-
means we are blocking the state. If we call the sleep method, we are blocking the state.
Yes, correct.
What we call join?
So
When do we
even
call?
join, when you call join, just now we observed here, right? When you call join, main method is waiting for this thread to complete, right? So until this job one is completed, this run method is completed. Where is that? This run method is completed. It cannot continue. The main method cannot continue. So main method enters the waiting state. When you call join, main method enters waiting state until when? Until this thread is dead. This thread is completed.
So what is
So
the
then
difference between yield and join?
yield will do nothing. It tells that if you call yield, it will just go into blocked state and go back to runnable state. Means it gives a way. We do not know. If you call T1 dot yield, you think that T1 is running. You see T1 is running, and you call T1 dot yield, means you give away to some other thread. So okay. So it comes to blocked state and it goes back to runnable. Okay, join will wait. Join makes another thread to wait. Okay, it will be in the blocked state until that particular thread. You are calling thread.join until this thread is dead. The main will not continue. Okay, we cannot be sure that if once you call yield, if you get the same thread again in the running state or not, we cannot be sure when you call yield. You cannot be sure when you try to synchronize some threads in two things. Okay, when you use priority and when you call yield. But you can be sure when you use sleep and when you use join. You set the priority. We are not sure whether that priority is considered or not. You call yield. You cannot be sure that whether that yield will give way to another thread to execute. But you are pretty bit sure that when you call sleep, it will sleep for that particular milliseconds and go back to runnable. When you call join, you are pretty sure that it will wait for that particular thread to die and then you start again. So these are the main difference when you call sleep and join and yield. The synchronization is 99% sure, 99.99% sure, but when you use yield, it is not at all sure. 99.99% it is not sure whether there is some synchronization in thread. Got it?
Yes, sir.
Any questions?
So can we get the details of the threads in the runnable pool by some method or something?
No.
So it's purely for the internal working of JVM.
Yeah.
Okay.
We do not know how does it work and how it schedules. It all depends on some algorithms. There was some algorithms I studied in my college: round robin scheduler, queue scheduler, stack scheduler. There are so many ways of scheduling things. It all depends on the processor. This all depends on the OS. OS schedules the processor to run the threads. Okay, it all depends on that particular algorithms they have implemented.
Okay,
so in running state there will be only one at a time. Okay, So only one thread, either main will be running, either or T1 may be running or T2 may be running. In running state, only one at a time. In runnable pool, there can be multiple threads. Okay, so you can enter running state only from runnable. You cannot enter running state from new or blocked or dead. Okay, you can enter from runnable state, enter from runnable state to running state. There is only one gate to running state, which is runnable. If there are runnable threads, then it can enter running state, and running state can have only one thread running at any point of time. Clear? Any questions? Any questions, guys?
No, sir.
So this is a bit tricky to understand. We have to imagine things like we cannot be sure of the output. If we can give some assurance about the output, so if you do this, you will get this, then we can, it becomes more clear. But when output is somewhat clumsy and confusing, then the threads are like that. The topic of thread is like that. So we have to bear with it, understand it. So we have created thread object. It has entered new state. Now I am calling thread.start. It has entered runnable. Now we do not know when. So we saw that. So main started before thread 1 got started, thread 2 got started or got executed, right? In yesterday's example. So we do not know which thread will JVM pick up. So or put it into running state. So we have started, that's our duty. And to run our program, to run our thread, it's the duty of JVM. It will pick up some of the thread and run it, put it into running state. If we call sleep, yield or join, that thread will go to blocked state and it will wait for certain time. If we call sleep, it will wait for that particular amount of milliseconds. Or if we call join, it will wait for that particular thread to end or go to dead state, and it goes back to runnable state. And now it is again the turn of JVM thread scheduler to pull it back to running state. Once all the thread execution is completed, every thread will go to dead state. If every thread is dead, then our JVM shuts down. So this is the recap. Cool. Anything else that you need to ask? Any lab questions? If you have certain doubts, please ask me. I'm really happy to help. Any questions, guys?
So I have a question not regarding what you have covered so far. I remember reading in that Java doc of thread that you should not start the thread which has already finished completion. Why is it so?
You cannot start the thread which is already started. Okay.
No, once the thread goes into the dead state, can you
how do you
restart
know? How do you know that whether that particular thread has gone to dead state?
Let's assume that we do thread.start and then thread.join. So we know that it's finished its job. And then after thread.join, we again do thread.start.
No, you cannot do that. That's syntactical. You cannot start a thread again which has already started. It once so it's a quite common sense. You start a thread, we do not know how it is executed, at what point of time it will go to dead state. We are pretty sure. So you call join on that thread and that is dead. Okay, that thread is dead. You cannot call the same thread which is already dead, which has completed that job.
Okay, but but the object would still be referenced in the heap, right? The thread object which is dead.
Yes, yes.
Okay, so fine.
So we'll just test it. If it will be in the heap. I'll just share the screen. So we have called start here. we have called join here. Okay. So before main ends, I'll call thread dot start again. Okay, it will raise an exception, of course. We cannot do that. So you see, illegal thread state exception. You cannot start the thread that is already started. We do not know, right? At this point of time, it may be joined and completed, but still JVM doesn't allow you to start the started thread again.
Okay, sir.
It's an exception.
Yes, sir.
Okay, cool. So it's dead. That thread object is, that particular thread process is dead. You cannot call it again. Any other questions? Okay, shall we end? Okay, see you guys. So please go through the videos. It will help a lot. It gives you more clarity on the topic. Please go through the videos. So we'll see next. Okay, thank you. Bye. Happy long weekend. I don't know when do we have the next session. So
bye, sir.
happy Navratri to all. Enjoy.
Thank
And
you,
Thank you,
don't
sir.
forget coding. Don't forget Java, JavaScript, React. Do some projects if you can, especially on React. Learn new things. Whatever is thought is basics, please dig deeper. Okay, you have very good chance in React. React's future is really good. Learn new things. Keep exploring. Okay. Cool. You need not remember everything. You do a project. You can forget it. No worries. But that gives you an experience. Like today, what happened? I do not remember many things. I do not consider it as my problem. So I read things, I understand things, I can explain it, but I cannot remember things. So, but I have this knack of managing things because I have coded that much. So if you can code that much, if you keep coding, so you need not panic over things. Okay, you do something, you don't get it, you try another way, you get it. So this is how coding works. Okay, you need not remember everything, a whole lot of things. Okay. Now, of course, I should remember as an instructor, but I do not. I cannot remember things much. So I keep coding. I keep revising. So keep doing that. You will become a better coder. I was really a not better coder. I was really poor at coding in the beginning. So I suffered a lot. But once you get into the habit of coding, thinking in the way of coding, then everything becomes easy. Okay, so this was I wanted to share. So happy weekend, happy Navratri. Bye bye. Thank you.
Thank you, sir. Bye.
Thank you, sir.